In this demo, I'll be showing you how to create a generic function that can be utilized with multiple different pieces of data. The first thing we need to utilize generics is a trait that we can implement for multiple different structures. So I'm going to create a trait called check-in, and this will be for an airport so they can check in cargo and passengers. The first function will be named check-in, and that will be for when a passenger arrives, they can check in, or if cargo or luggage gets dropped off, the check-in will be when it's initially received. We then have a function named process, and this will be after the passenger checked in or the luggage was checked in. Then process would be the passenger boarding the plane or the cargo being moved to the warehouse to be placed onto the plane. We then need to create some structures that we can work with. So we'll create a pilot, we'll create a passenger, and we'll create some cargo. So these will be the structures that we're working with. We then need to implement our check-in trait for these three structures. So I'll do pilot first. So we'll implement check-in for the pilot structure. So we'll need a check-in function, and we'll need a process function. So for check-in, we're just going to print out checked in as pilot. And for process, we'll do pilot enters the cockpit. So that'll be the messages displayed for each function for a pilot. So what's going to happen when we check in a pilot? We'll call the check-in function for the pilot because we have the check-in trait implemented for that pilot. We'll then get the message checked in as pilot. And the same goes for process. So whenever we call the process function for a pilot, we'll get this message. I'm now going to implement these functions for passengers and cargo. For the passenger and cargo implementations, I'm just going to copy the existing pilot implementation. So we'll change this to passenger, and we'll check in as a passenger. For the processing messages, we'll have passenger takes a seat. We'll copy it one more time for the cargo. So for check-in for cargo, we'll have cargo checked in. And then for the processing message, we'll do cargo moved to storage. Now that we've created our three structures we're going to use in this program, and we've implemented the check-in trait for each one, we can write a generic function that operates on the check-in trait. I'm going to name the function process item. I'm also going to bring in the check-in trait. That way we can see it while we're working. I'm naming the function process item because we can implement check-in for anything. It's not just restricted to the few things that we created. So this function will be generic over some type t, and that type t must implement the check-in trait. So when we create the t, this will be our function parameter for the function, and the check-in here, this is the trait that the t must implement. If we try to run the process item function without providing a type that implements check-in, then we'll get a compiler error. For our function parameters, we're going to have a item, and that will be some type t. Within the function body, we'll do item.checkIn, and we'll do item.process. Whenever we run the process item function, we require an item, and it must be some type t. So when working with generics, it's some type t. That some type t must implement the check-in trait. The check-in trait guarantees that we have a check-in function and a process function. Since the type system guarantees we have those functions, we can run the check-in function and the process function on that type. Let's go ahead and make some data, and we'll run these functions to see what happens. So down here in the main function, we'll create a passenger. We'll name him Paul. We'll create a pilot. We'll name her Kathy. And we'll create some cargo. Let's call it cargo 1 and cargo 2. We'll then use the process item function on Paul. And we'll do the same for Kathy and for the cargo. So when we run this program, we should get messages for a passenger, followed by messages for the pilot, then messages for the cargo, and finally, another messages for cargo. Let's hop into a terminal, run the program, and see what we get. So here we have passenger check-in, and then we have pilot check-in, and then 2 cargo check-ins. So the program's working great. Let's hop back into the code to see exactly how it works. If we go up to our process item function, whenever we supply some data that is a check-in type, it creates a separate process item function specific for that type. Since we're working with a passenger, pilot, and cargo type, we'll end up getting 3 process item functions, each one specific to these 3 types. While this is just an implementation detail, it is important to understand that every time you create this function and run it with different pieces of data, that you'll increase the size of your binary. However, your code will run extremely fast because each type of data knows exactly where the function is located in the process memory. This also has implications later when we try to make vectors using different types of data. This concludes the demo on generic functions. I'll see you in the next presentation.